Well, hi, good morning, and thank you so much for joining me in my shop here. It's November 20th, clear skies and very, very cold outside. It's -6 this morning when I got up. Couldn't convince my cats of that. They had to go outside and experience it for themselves, which they did. Two sad cats now. Okay, so I've completed the alignment, at least the first pass alignment on the intermediate transformers, intermediate frequency transformers, and now it's time to do the rest of the RF alignment. And the first step usually with these radios is to make sure the pointer is pointing in the right place. A little tough with this radio because it's when it's out of the cabinet there is no dial screen. In fact, the dial screen is sitting right here, dial glass. So instead with this radio they've put a chart on the back of the big wheel, which we have to depend upon, and it's calibrated in degrees. So by looking at that chart, we can make a judgment as to the position of the pointer, bearing in mind the pointer's here in my hand, for crying out loud. It's not even on the string. So when the pointer gets put on the string, it can be put on in different places on the string too. So I haven't read anything about that just yet. But let's take a look at the instructions. This first part about how to get the wheel and the pointer and everything ready for this next stage of alignment here. So we'll start right up here at the very start of the alignment procedure. So we'll be doing the output. We won't even be doing an output meter alignment. Instead of putting a meter on the speaker, which is what this is recommending, I'm going to monitor the AVC voltage. My meter is high enough impedance it can do it. So I don't think there's a problem there. That's what I'll be doing. Cathode ray alignment, I may do that at the very end. But for now, a meter is going to do the job. Test oscillator for all alignment operations. So low side to the ground terminal. Keep the out to the ground terminal. Connect the low side to the ground terminal. I didn't say chassis. I said ground terminal, but I think in this radio they're exactly the same thing. I remember looking at that, which most radios they are exactly the same thing. Keep the output low to avoid AVC action. Calibrate, so I need the output to be high enough to cause AVC action so I can see the meter move. So I'm really not following these instructions the way they're suggested here, but I will keep it as low as I can get away with. Calibration scale on the indicator drive cord drum. So that's what they call the big wheel. I call it a big wheel. They call it the indicator drive cord drum. Tuning dial is fastened in the cabinet. That's right, the tuning dial fastened in the cabinet cannot be used for reference during the alignment. I showed you that on my bench. Therefore, a calibration scale is attached to the rear of the drum, which is mounted on the shaft of the gang condenser. The setting of the gang condenser is read on the scale, which is calibrated in degrees. The correct setting of the gang in degrees for each alignment frequency is given in the alignment table, right there, 28.5 degrees. As the first step in the RF alignment, check the position of the drum. The 180 degree mark on the drum scale must be in a vertical position when the plates are fully meshed. The drum is held to the shaft by means of set screws, must be tightened securely, and the drum is in the correct position. So, now, is the drum in the correct position? Probably is, but we're going to have to take a look at that. Let's read this last bit. Pointer for calibration scale. Improvise a pointer for the calibration scale by fastening a piece of wire to the gang condenser frame and bend the wire so it points to the 180 degree mark on the calibration scale. Now, when I set up the radio, and I've done this already, I pointed it to the 0 mark, and it's not the same location as the 180 mark when the capacitor is turned all the way. But we're going to have to look at that too. So start with this. 180 degree mark on the drum must be in a vertical position when the plates are fully meshed. Okay, let's take a look at the deal here. So I do have a camera positioned up here in the radio. It's right there, in fact. So it's looking at that drum scale. Let's take a look at it. So my camera has drifted a little bit here. Let me Let's just re-aim it a little bit here. There we go. And I think I'm going to have to stop the automatic focus on it. Just bear with me a moment here. The automatic focus really gets fooled by any kind of pattern, like a screen type pattern or something like that. Okay, that's about as good as it's going to get right there. That's certainly good enough. Wait, what happened? What? Hang on a second here, I did something dumb. I don't know how that happened, but anyway. Somehow the automatic focus came back on. There we are. Okay, now we can get to work. So I will turn the capacitor all the way closed. Now don't worry about where the pointer's pointing. And in the camera, straight up is not straight up in reality. But you can see the top of the frame of the capacitor. This line right here. This part right here. Oh, no. Oh, that's interesting. So, yeah. Okay, Jim. The radio's on its side. Okay. Try and pay attention to what you're doing. This is the top surface, as if you didn't know that already. And that's level. So it should be at right angles to the 180. It looks to me like it's right angles to the 185. That's what it looks like. It looks like the wheel to me should be something like that. But it's way over here. I don't want to adjust. I don't like the idea of adjusting the big wheel. It's very awkward to get into the set screws, but how can I be absolutely sure? Because, I mean, this is the kind of thing that should be done in the factory and never be off. Yeah, it could just be the funny angles of the camera. Okay, let me look at this from a different angle here. Look at it myself here. Yeah, the camera's throwing it off. And when we look at it through the camera, we don't see it right. So when I look down here, oh, it does look off. Wow. This is a bigger problem than I kind of thought. What I'm going to do is try to lay a straight edge up in there that we can work against. How am I going to do that? Stabilize this. This ruler's too big. Ruler too big. Need something much shorter. How about this piece of wood here? Laying it up on a flat piece of the edge of the side of the oh my gosh, this is not easy to do here. Well, maybe like this. Laying it up against the flat edge, and it turns out the flat edge actually has a rounded part. So this piece of wood is now straight vertically. So I compare it to the lines and make sure that they are also straight and vertical. But again, the camera you're looking through, it's got to be misleading here. Okay, so the 180 is where the circle is. That would be straight there. That would be straight up. Look at how close the white pointer is. It doesn't quite look straight in the camera, but that's okay. I got to decide if I want to try to loosen the big wheel and adjust it or not. Because the setting right now, let's just count the numbers there. That's 70. It's 178. It's at 178 on the pointer. If I set the capacitor closed, that's where it actually ends up. So it's this far out by my reckoning. You know, a good thing to go drink some coffee and think about this. This is really worth doing. Okay, a little bit of coffee says, look more closely at the situation. The set screws are square-headed set screws. They're not hexagons. So the chance of me having a tool that fits perfectly on them is low, in fact. But maybe I do. So I'm checking different sizes of hexagonal sockets and see if one of them just happens to fit on there and grip it. If it does, then I will think harder about resetting the position of this wheel. So, okay, I got lots of these to try out. Well, despite trying all these, most of these are the same, 2 or 3 sizes here. None of these are going to grip the top of that set screw enough that I can risk loosening it and tightening it. I might be able to get it loose, but I may not be able to tighten it up enough. And I think that's a big problem. So at this point, well, I can't do it with this kind of tool, that's for sure. If you reach in there with long nose pliers, yeah, kind of a similar problem. You can't get enough, work on it to. Hey, are you Canadian? Are you like me? Is all your metric and imperial all mixed up together in containers like that? Are you constantly flipping back and forth between metric and imperial? It drives me nuts, actually. Okay. Well, I'm going to reach in with this pair of pliers. We'll see what happens here. Just as a practice. Well, I can certainly get down there and get a grip on it, but it's right at the tips. What's another way? Another way would be to recalibrate the what do you call it? The scale, and just leave everything the way it is. Well, that would make sense. Does that make sense? Well, the problem is that you could do that, I guess, but the wheel would come to an end too early or too late when it got to the end of the capacitor, I think. I don't know. Am I thinking straight? Am I splitting hairs here? I'm definitely splitting it. It's a pretty fat hair. I'm splitting a fat hair. I gotta think more about this before, because when you're in the potential to make a big mistake, I don't want to make a big mistake. Coffee will help. Okay, made my decision. I'm gonna leave it just as it is. I'm going to carry on, going to follow the instructions, going to pretend that there's no problem up here and just use the numbers that are in the chart and just do the alignment. And then when that's done, I can check the result, and at that point I can make a decision whether I think I should put more effort into it, move that wheel, or do something like that. That's what I've decided to do. Okay, so we got to read those instructions some more here. Okay, let's just read these notes that are underneath the diagram here. All adjustments indicated above, except operations 3, 4, 5, and 6, are made with antenna link in the open position. all the adjustments except 3, 4, 5, and 6. Except 3, 4, 5, and 6. Radiated signal. That's kind of weird. Let's read that. Radiation loop comprising 2 turns of wire 18 inches in diameter should be connected to the test oscillator and placed 4 feet from the receiver. Well, this is kind of weird. What is the receiver got for an antenna under this arrangement? Or tell me there's a complete loop antenna missing from the radio. There was a loop antenna on the back and it's gone. Wait a minute, let's just go up here. It's not gone, it's wait a minute. It's on the side of the radio, Jim, for crying out loud. This is mounted on the side of the radio. I kind of forgot. Oh my gosh. Okay, well that's important to know. That explains the make a loop and radiate the signal at the radio. How ridiculous is it that I there's a loop antenna staring at me the whole time, and I just sort of somehow got it in my head it was missing. Okay. Odd, you're going to radiate connection to receiver, antenna terminal, 3, 4, 5, and 6. 3, 4, 5, and 6. Well, I think they made a mistake here, and 6 shouldn't be in this list. It should just be 3, 4, 5, just as showing up here. Look, this last one is done, it's a shortwave thing. Now, there's no way you're radiating, you're going to be using a wire antenna, or in this case, connecting direct, which is, that's an error. That's an error in here. You know, the number of times I found errors in these instructions is starting to make me unnerved. Because when I find an error, the first thing I think is, it's not wrong, I'm wrong. There's something I'm getting wrong here, but I don't think there is. Okay, let's continue reading the actual instructions here. Spread band alignment. Well, wouldn't you start with the band C? Like band C. Yeah, you start with band C. Spread band alignment. Well, so they aren't giving step-by-step instructions on the alignment. This table is the step-by-step instructions. That's what they're doing. So this is all notes. This whole thing, I think it's just special notes here. Let's read it. Spread band alignment. The most satisfactory method of aligning or checking the spread band ranges on actual reception of a shortwave station of known frequency by adjusting the magnetite core oscillator coil for each band, so these stations come in at the correct points on the dial. And this is something really, if I want to get it really right, I have to do it with the radio back in the cabinet and the pointer behind the dial. Hey, you know what? It didn't say anything about where to put the pointer on the string. Did it? It did not. It did not. Calibrating prize a pointer. That's different. That's pointer for calibration scale. Well, maybe it says somewhere else. I mean, once again, let's see. Maybe it says here, calibration indicating tuning dial is fastened in the cabinet cannot be removed. Blah blah blah. Put in the scale. No, they don't actually say where to put the pointer. Well, I'll just have a free hand in that, I guess. Okay, spread band alignment, most satisfactory method. Right. In exceptional cases, when the set is being serviced in a location where the noise level is high enough to prevent reception of shortwave stations, a test oscillator may be used for alignment, but an extremely high degree of accuracy. Back in the day, they did not have, frequency counters that would count frequency down to a hertz. They didn't have that stuff. So knowing the frequency was a really big challenge, especially for a small shop. So that's why they're saying use a known station. And then you could calibrate your test instrument using a known station. I guess there's zero beating the test oscillator against a shortwave station of known frequency. Yeah, like for instance WWV. Hey, yesterday late in the afternoon I was picking up WWV at 25 megahertz, and that's the first time in, I don't know, 25 years I've heard it at 25 megahertz. I was hearing it 25, 20, 15, and 10. All those I could hear WWV late in the afternoon yesterday. Zero beat. Use harmonics of the standard broadcast range of a test oscillator for first checking the frequency settings on this range by means of a crystal diagram. Yeah, we don't need to worry about any of this because I have a frequency counter, because it's the year 2023. When a test oscillator is employed for spread band, an initial check should be made on the actual reception of shortwave stations of known frequency, and the magnetite quality band can be adjusted so that station comes in. Isn't this... Wait a minute. Oh, when you use a test oscillator, then afterwards you should verify it. Because they don't know what frequency they're on, because no digital equipment. No final spread band adjustment made with a chassis fastened in the cat of the pointer, and the pointer accurately aligned to the dial. But they don't say how to accurately align it to the dial. So I guess what they're suggesting is you do all this work, then you put the radio in, and you slide the pointer around until the pointer is pointing at the frequency you're listening to. And then it's in the right spot. That must be what they're suggesting. This is more instructions for doing what they call the keyboard. Boy, that's a generous term to apply to a set of push buttons. Keyboard. Okay, I think I'm ready to go here, so we will start. I will arrange this arrangement. Maybe all we're going to do is the AM band today. I don't know. We'll see. It's a little late in the morning here for me. Radiate a signal at these frequencies and adjust L17, C27, and C4. Okie dokie. Okay, now that I've just come to realize there's an antenna sitting on this radio, I realize also that I was doing some stupid stuff in previous videos trying to pump broadcast signals into the antenna back here and getting bad results. But it's because this is the antenna and you can't, well, maybe you could pump them in through here. Well, we're just going to do what it says. So I have a large loop antenna just behind me here. It's hooked up to the signal generator. I'll put this down to, what was it, 16? Well, let's just get it in the range there. Turn on the radio now. It's been a couple days. I've done a couple projects in here that were not video worthy. Perhaps I've left something here I don't want here. Just before I turn the radio on. Excess leads everywhere. Here, that's better. Okay, now this antenna is polarized or angled this way, and the transmitting antenna is sitting this way behind me, just behind the camera here. So that's not quite right, but hopefully there's enough signal getting into the antenna. It's going to work. You'd be surprised if it doesn't. Okay, so we want to turn on the radio now. Is everything okay? I also have this meter ready to go. This set to negative. DC, and then the volts are down this way. So I could set this down here, and then it's going to read the AVC voltage for us. That will help with any alignment work. Okay, Mr. Radio, on you come. Okay, I think the radio is maybe switched off. Switch it on. There we go. Give it a moment. Now, we've got to make sure it's on the, I'm going to spin this thing right around, because I don't want it this way anyway. That's good. Turn it on and then spin it around. It's not the best order of operations here. thing yet. Okay, so that would be the broadcast band. This would be the antenna. The actual antenna's come loose here. That's okay though. So we want to tune this somewhere to, we want to tune it. Let me just look at the instructions here myself. So we'll pick, let's do 1500, that's 19.5 degrees on the chart. 1500, 19.5. Okay, 1500, 19.5 here. 1500. Okay, 1500, 19.5. Okay, I'll put the dial up. Let's see how well this works. 19.5. Okay, didn't hear a thing. Just lots of noise. Okay, what I'll do is, oh, I don't have the signal generator set very high. Let's try it like that. Let's go higher. Okay, there's no higher than that. The loop I'm using is actually attuned. My pointer's off. Okay, everything's a little off here. Okay, well, we're supposed to be picking it up somewhere in this range. What I'm going to do is I'm going to grab another radio here. Figure out how the camera works. Yeah, figure it out. There's the radio. Yeah, that's not working. I make sure the signal generator is actually transmitting. 680. You know, you hear her say, we want to make sure that we use all the levers to get social housing, and then she continued to the levers. Picture this. Every country has a central bank, or most countries have a central bank, and the central bank is operated usually by a panel of people, often other bankers. They sit around a table every so often and discuss the big issue. What should the interest rate be? That happens in Canada all the time with the central bank. So picture these guys, these highly paid, highly educated, experienced people, very serious in what they're doing, sitting around this table having a very serious discussion about what they should do about the economy, an incredibly complex machine running in every country. And these guys sit around and talk, and just beside the table is a single lever. And all they got to do is decide to push the lever this way or push the lever that way, because all they've got is interest rates to adjust. And those guys just got to think really hard. Should we push it this way or that way? It all comes down to one lever. That's my point. Okay, let's get back to this. There's a loop antenna in here. Ignore the red wire. There's a loop antenna inside here. Okay, I'm going to tune the antenna here. There we are. Now it's sending out a strong signal. Very strong signal. Perfect. Okay, I'm going to knock this back one. one shot. Okay, now we know it's working. We know it's working. Can we pick it up with this radio now? Let's go back and look at the dial. This is a good test of the calibration of that dial too. Wow. It's a little bit surprising here. As I turn this dial, we're going down in frequency, away from 1500. Okay, so I'm going to move the transmitting antenna right up close to the radio here. Okay, it's getting a little awkward for me. It's up here. There it is. Way up at 30. Now I'm going to move the antenna away. I wonder if it's because oh, you're over here. Where are you? Where? I cannot. Oh, it's here. Okay, so I got one antenna this way and the other antenna that way. So I'm going to turn the transmitting antenna to be of the same polarization as the radio antenna. So that improved it quite a bit. So that's part of the problem here. Is we've got the loop antenna is polarized differently. Why 4 feet away? Holy smokes. Okay, we got this working. We sort of got this working. All kinds of stuff happening here, crazy stuff. What are we going to do about this now? It's up at 40, up at 30, and it's supposed to be at 19, but the dial's incorrect, and everything's incorrect everywhere. Everything's incorrect. Go to the other end. Let's go to the other end and see what's happening there. So the other end, I just flip cameras here. The other end is, I'm looking at the chart, we find 600 at 147. 600 at 147. Okay, so 600. 600, 147. Turn that down a little bit. 147. I'm going to stop for just a second here. Okay, let's keep going. Now we can see the chart right on the screen too. Good. Where did the signal go? What did I do? I'm standing. Did I do? What the heck did I do? Did I do something? Oh, we're never mind. Ignore everything I'm saying. I'm just losing my mind here. 147. Let's go there. It was 147, wasn't it? So we see this is way off also because it should be here. For 600 and 140, we're getting it way up here. Now, is that because it just got the whole wheel incorrect? It's roughly the error in the wheel, isn't it? Jim, you're paralyzed once again. Paralyzed. Paralyzed. It's really a drag doing this without the actual dial and pointer and stuff. There's really no way to kind of rig that up. I just noticed too is the pointer I showed you previously in my hand is for another radio. The pointer in this one's right here. So many decisions. I gotta stop and think about what I'm doing here before I just make a big mistake. I'll just turn it into a small mistake. Okay, let's see how this works out. I think I got everything on the screen there. So we want to start with line number 3 there. Radiated signal, 600 kilocycles, and L17. That's the one thing I didn't. Where's L17? Where's L17? Isn't it down here somewhere? Where do they tell me? L17. L17 here. A oscillator, 600 kilocycles. Right in there. Wow. One thing I didn't figure on was how awkward it is to get at these. At this. Oh my gosh, this is. It just fell off here. This meter is reading the ABC voltage. So I am supposed to. Oh my gosh, how am I going to get in there? Really? Way in there? Things are going downhill here. Okay, let's bring down this light here. I still have the radio also running on limited power. I'm going to put it on full power and just see if it drifts. So keep an eye on this meter. It's liable to change a bit. It may not indicate a drift. Yeah, so I don't think the radio drifted. It just got louder and better. No? Okay. So I could actually leave it on the lower voltage, but we'll carry on like this now. So I'm trying to figure out how to access. How many are there? There's 3 of them up in there. Wow. And they're slotted top. I can't see the last one. I have the camera right in the way. Oh boy, oh boy, oh boy. Can't even possibly get a tool in there. Good luck on this. Settle in. Come on. Okay, see the slot. See the angle. Got it. Okay, I got it. Okay, we're in business. Now what am I doing? So I want the tuning dial to read 147 when we're done. Okay? Let me just make sure we're right at 600 here. Okay. Okay, 147. Apply the precision. pointers, everything's wrong. And I got a cat at the door. Okay, I gotta watch the meter now. Yeah, Peanut, I hear ya. So now when so it's 147, I better just check that. 147. So now we're going to go to 19.5 and do the 1500. So we're going to go to 19.5. Really? 0.5? Who are they getting? Here we are, 0.5. And this is 1500. Yes, 1500. Actually 1580 or so. Maybe get down to 1500. Okay. We are adjusting now. What are we adjusting here? We are on line number 4. We are adjusting the A. No, adjusting C27. C27. C. So here's C27. Also in a bit of an awkward location. Gotta do it with a screwdriver. A long shafted, narrow screwdriver. That's an awful lot of metal here to bring into the deal, so this might affect the rate. How come we're hearing it? Oh, because I'm at 1570. So first thing I want to do is tune this in the direction we want to go. You notice that I often do this using SDR-based techniques, and I'm not on this case. So why? I don't know. Honestly, I don't know why I'm doing it this way. Because we can do the SDR, read your local oscillator thing. Come on, flashlight. Oh yeah, which one of those three? It's this one here. It doesn't seem to affect the radio when I touch. I can't see the slot. I must see the slot. Show me the slot. There's so much dirt in there. Okay, I think I saw it. On this angle here. Screwdriver here. Definitely saw the slot. We're in. Okay, good. I like the stiff screwdriver. So now we're ready to go to 1500. Watch this meter. This way. Don't come out. That's 1500. Now we peak the meter. Where's the meter? Things seem a little jumpy. From that. I'm going to pull the screwdriver out and it's going to change. Nope, didn't change. Okay, that's got it. That's 1500 at 19.5. Very good. There's one more adjustment to make here. That's this one right here, C4, doing the antenna adjustment. C4, where is C4? Right on the antenna, C4. You on the capacitor? C1. Hey, where's C4? There it is. Right down here. That's right in here. Okay, we're going to try it with the big screwdriver again, but put it in there and see what happens. How am I going to do this? Just touching the chassis is making noise. I don't think this is going to work like this. On a bit of an angle. Need a shorter screwdriver for this. Try this little tiny guy here. Ooh, that's tough too. Get your fingers in there. How are you supposed to do these things? And you're supposed to put this back in the cabinet and repeat these exact things I'm doing right now. Your hands are supposed to come in through here. Whew. Now I've tightened it up because I got this rack here, I got the camera here. I mean, I've made it difficult myself. I don't know how you can do this. How can you do this? You need a really long in here, then I've got to put some. Oh, I got it in. Huh, I did like that. Didn't even mean to. Okay, let's just read the instructions again. What did it say? I think you're just peaking this up. Doing it at 1500. 19.5. Yep. We just peaked this. We just peaked this. And it just fell out. Ah, son of a gun. I don't think I can turn it with this anyway. There we are, we're in. I can't get power on it. Oh my gosh. I need to try something else here. Look at this. Handle. Okay, get it right. Get in there. I'm in. Okay. Now we gotta watch the meter. Okay, turn, baby. Down. Went down. It's going up, 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 and up. So I got jammed. End of the line. It's as tight as I can't turn any. These are weak. You can't put too much pressure on it. Got it to go up. Looked like there was more to go though. Back to my long screwdriver here. Let me turn this down a little bit. Okay, I'm in. Watching the meter now. Oh, it's going down. So I actually got it to the peak and didn't realize it. There we are. She's peaked. Okay. What we want to do now is we want to listen to some AM radio with this. I'm going to set something up for that somehow. I don't know how. Okay, I'm going to have you watch this from way over there. So first we want to get this antenna out of here. Need the signal generator. Okay. So this antenna is really in the wrong angle completely. Let's see what it'll do anyway. French station, pretty good. It's a good sign right there. Another station. So if you're new to my channel, what you wouldn't realize is that for the last 10 years I have not been able to tune a radio like this in my shop because of noise interference, tremendous interference coming from two computers in my house, which I've eliminated. Consequently, with that noise gone, all of a sudden everything works a lot better. Fantastic for me, really. So, yeah, it's working good. Some noise there, I don't know what it is. Good, okay. Well, that was a really rough, another rough session in here when you think things should be pretty simple, and like every step of the way something crazy is happening. But I think I got it aligned now. Is it aligned the way it really needs to be? We won't know until it's right back in the cabinet again, unfortunately. So there's a little more alignment effort to be done on the short wave bands, and then the radio's aligned. If its performance is good, I'm done. Then it's all about getting it back in the cabinet, getting the pointer in the right place and all that. Great, okay, what am I off to do now? I'm off to do grocery shopping. So thanks a lot for watching, and we'll see what happens next. See ya.